It's time for another video using Microsoft Excel for our statistical analysis. In this video, we're going to look at a multinomial categorical variable. In other words, a variable that has more than two possible outcomes. I'm going to use a little example where we have three levels, and we're just going to imagine that it's some healthcare facility that admits patients, and they're going to categorize their age. They're either going to be young, adult, or the aged. Now, I hope you've watched some of the previous videos in this series, and especially that first one, because I'm going to go over the button presses, etc. quite rapidly. So here's our data set. I've got a column ID column. It's the sequential numbers for each of the subjects. And then we have group. So we're just looking at the group of individuals, and they have been categorized by their age. So we see the aged, we see adult, and we see young. So just three different age groups. I'm going to select all my data. So I'm going to go to cell A1, hold down Shift Command or Shift Control, right arrow, and then down arrow. Control Command C to copy. I see the marching ants are going. I'm going to open a brand new sheet. I'm in A1, drop down next to paste, and I'm going to say paste values. Let's increase the screen size a bit. And again, I'm always going to change this into a table. So I'm going to go to insert. The third button across is table. My table does indeed have headers. In my first row, I do see the variable names, and I'm going to click OK. There is my data. So let's rename the sheet. This is my copy sheet. Excellent. So let's make a new sheet, and I'm going to call this sheet proportions. This is where I'm going to do my analysis for my chi-square test for proportions. So once again, I'm going to paste my data, paste the values, and you remember you can always copy it from the original. Let's increase the screen size a bit. And once again, I'm going to go to insert, and I'm going to change this into a table. I do see the selection. My table does have headers once again, so that's fine. Now, the one way to summarize a multinomial categorical variable such as this, remember we have three levels. We have young, adult, and aged. We are going to use a pivot table. So I'm going to click inside one of the cells. I'm going to go to insert and hit the first button, which is pivot table. And because I have already clicked inside of the table, that's automatically going to be selected for me in the select a table or range. I just want to put my table into this existing worksheet. So I'm going to click existing worksheet. I'm going to click the selector button, and let's go to cell number E1. Expand again and hit OK. Now I'm going to take my group column, drag that down to rows, and I'm going to click, drag, and hold again group down to values, and by default it's going to do a count. So let's look at this. There were 74 adults, 51 aged, and as far as the young were concerned, there were 32 for a grand total of 157 subjects. So let's do the following. Let's have a look at the null hypothesis. And then we're going to look at the young, the three levels, age, the adult, and the aged. And under the null hypothesis, let us suggest that by some previous count, maybe, there's been data for many, many years, it looked like the young was 0.2%, the adults were 0.6%, and the ages were 0.2% as well. So under the null hypothesis, previously in this clinic, 20% were young, 60% were adult, and 20% were aged. Now we want to see, based on the data that we've collected, are those proportions different? And so the null hypothesis would be, these are the proportions. My alternative hypothesis, these are not the proportions. So let's see, under the null hypothesis, what would we expect? So if the null hypothesis was true, that the proportions were 20%, 60%, and 20%, and I have 157 subjects, what would I expect? So it's very easy for us to work out what these values are. So equal the 157 times 20% of them. And that is 31.4. So let's do the next one. Under adult equals out of 157 times, clicking on the 0.6, that gives me 94.2. And then once again equals the 157 multiplied by the 0.2. So I'm just clicking on those values. So if the null hypothesis was true, that the splits were 20%, 60%, 20%, and I had 157 subjects, under that null hypothesis, what would I expect? Now, you're always going to get, not always, but you will get these decimal values. There's no such thing as 31.4% of a human being. But from 157, if that's what I expect under the null hypothesis, these are the values that we would get. What did we observe? So I'm going to type observed, and I'm just going to say equal, and click on for the young. There we go. It was 32. That's fine. You can just type in the numbers if you wanted to as well. For the adults, there we go. It was 74. And then for the aged, I'm going to click equals. And on the aged, that was 51. So there's the difference between what I would expect if the null hypothesis was true and what I observed. And now I can calculate an x squared statistic. First of all, let's do the following. Let's do the terms inside of my equation first. So that's going to equal, I'm going to do open parentheses, that is observed minus expected, close parentheses, shift 6 for square, and then divide by expected. And all I'm doing, I'm clicking on those values. So there we see the value for observed minus expected squared divided by expected for young. Let's do the same for the adults. So that's going to be equal. I'm going to open parentheses and then observed. There's my 74 minus expected 94, close parentheses, and square that. And then forward slash for divide by expected. So I'm just clicking on the 94.2 again. So we see the value there for that difference between observed and expected. Let's do the same thing for the aged group. That is going to equal, open parentheses, observed. There we go. It's 51 minus expected. I'm clicking on the 31.4, close parentheses, square that, divided by clicking on the 31.4 again for expected. And so there we see that difference. Now we can work out our x squared statistic. So let me type x squared there, and that's going to equal the sum. And so click on sum there, and I'm just going to click, drag, and hold all the way across. Close my parentheses, and there I see the sum. That's quite a large x squared statistic. So much so that we can start doing our statistical analysis. Let's think of the degrees of freedom. And I'm just going to expand between E and F there. There we go. And so the degrees of freedom is going to equal the number of classes that I have, the number of levels. That's 3 of them. We have young, adult, and aged minus 1. So that's on 2 degrees of freedom. Let's choose an alpha value. Let's choose 0.05, 5% as our level of significance. And now we can work out what the critical value should be. So the critical value, the way that I'm going to do that is to say equals. I'm going to say chi squared. There you see chi sq.inv. The probability is going to be 1 minus my alpha value. And my comma, my degrees of freedom, I've got it right there, is 2. Close my parentheses, and we see a critical value of 5.99. And our test statistic 16 is much bigger, much larger than 5.99. So by the critical value approach, we reject the null hypothesis. We say that according to the data that we collected, the proportion distribution is not 0.2%, 0.6%, and 0.2%. In fact, it is quite different, and you can work out those proportions. Let's calculate a p-value. That is going to equal 1 minus, because remember, with this, we're always going to calculate from the 0 side. The chi-square statistic starts at 0. It's not like the z statistic that's symmetrical from negative infinity to positive infinity. But still, we want the upper tail. So it's going to be 1 minus chi-square, and then you see chi-sq.dist is one that I want. X is my x squared statistic, so that's 16, comma, my degrees of freedom is 2. I'll click on the 2, comma, cumulative is 2, and I can close my parentheses, and there we see a very small p-value. Indeed, it is smaller than alpha. Once again, I'm deciding to reject the null hypothesis. So let's just work out the proportions of what we had. So let's put out here observed proportions, which is what we're going to do because we did reject the null hypothesis. So we will have to present what these proportions are. So that's going to equal, and let's do these as a percentage. I'm going to say equal. Now we observed 32 divided by the sum total was 157 times 100%, and that's 20.38%. Let's do the same for adult. That's going to equal, how many did we observe? 74 divided by the 156, let's multiply by 100, and it's 47%, and then equals we had 51 of the aged divided by the sum total of 157 times 100, and that's 32%. So we can see the differences were not so much in the young, but there was a big difference between the proportion under the null hypothesis for adult, which was 60%, and we only found 47%, and for the aged, which under the null hypothesis was 20%, and we found 32.5%. So once you've rejected the null hypothesis, please then put the proportions that you have actually found. And this is one way to use Excel to do a chi-square test for proportions if we have a multinomial variable.